In this video, I'm going to go over section 4.6 inverse relations and functions from day one. So we're going to look at examples 1 through 3. So we will be able to find inverse relations algebraically and determine if inverse relations are functions. So we're starting with the definition of an inverse relation, which is that an inverse relation is formed when the roles of the independent and dependent variables are reversed. So recall that a relation is a set of ordered pairs x, y, where x is the independent variable and y is the dependent. So that means that in the inverse, we switch the roles of x and y. So the point x, y in the original relation is the point y, x in the inverse relation. So an example of this is with these tables. We can see that the original relation is the set of ordered pairs -2, 1, -1, 4, 0, 3, and 1, 1. To create the inverse, you simply switch the x and the y. So the new points are 1, -2, 4, -1, and 3, 0, and 1, 1. To determine whether something is a function, notice that in the original, all of the x's map to one y. So all my x values are different versus in the new inverse relation, I have two repeated x values. Two of these points have an x value of 1. And what we notice if we group them in order now so that they're together is that the y values are different. And so since that one x value, +1, maps to two different y values, 1 and -2, that means that this inverse relation is not a function. So we'll be doing that with tables of our own. So given the table on the left-hand side, we are determining the inverse by taking and switching the x values and the y values from the original function. So for each of these, we're going to make a table. To create that table, we're literally taking every x value from the original relation, and it's becoming a y value. And all of the y values are x values in the inverse. So that means that each point I'm taking and switching x and y. So our first point is -1, 9. So that's going to change to 9, -1. Our next point is 0, 7. So that's going to change to 7, 0. Our third point is 1, 5, which is going to change to 5, 1 in the inverse. 2, 3 will become 3, 2 in the inverse. 3, 1 will become 1, 3 in the inverse. And finally, 4, -1 will become -1, 4 in the inverse. So if we're looking at the x values only, so if we're looking at the x values only, if none of them repeat, which is the case here, all of these values are different, then yes, the inverse relation is a function. And so remember that we're looking at this because no x values repeat. And so if they did, that would mean that it is not a function. Okay, so just a little reminder of how we figure that out. So looking at problem B, our table has the first point of -2, 4. So that means the inverse is going to have the point 4, -2. And then 1, -1, 0, 0. 1, 1 is going to switch and stay 1, 1. 2, 4 is going to switch to become 4, 2. And finally, the point 3, 9 maps to the point 9, 3. And so when we're asking if this inverse is a function, we're looking at the x values. So notice that we have 2 points that have an x value of 4. We actually also have 2 points that have an x value of 1, but this one situation is enough to tell us that no, this inverse is not a function. And so really what we're looking at is repeated x values. Oh, I guess I should say at least one repeated x value mapped to a different y value. So that's what tells us that the relation is not a function.